Okay. So intelligence is basically something the living beings have, where the uh, non-living objects doesn't have. That is basically what is intelligence. That means we try to understand the nature to survive, right? So that is we have to model, like as born as be living beings, we have to model the nature so that we can survive from death and find food and reproduce, right? Those are the main things all the living beings do. So in order to do that, we have to understand the environment and predict what is there, what is going to happen, what is around us, with the data that we don't have, right? So, for example, what happens in the next moment, whether a lion will come and kill me, or whether there is any waterfall and I would fall into it, and I would drown in the river, kind of thing. And how can I find my food if I'm a lion or someone? How can I find the food that I want? How should I hunt? What is the path I should follow? That kind of thing. So that is understand. So how our prey would behave. So we have to understand how the nature works. That is intelligence. The artificial intelligence is basically mimicking the living intelligence, right? For example, uh, we have, as living beings, we have some kind of understanding. So that understanding can come either from the learning, or it may be inherited from our genes, right? For example, when a child is born, he knows how to suck milk from his uh, so her mother. So how to find the food, and when he doesn't have enough food, he knows how to cry and get this food. And if it was a small baby cattle, uh, he knows how to find his food and drink milk from the his mother cow. Those things are not have not come from learning, right? So obviously, no one has told small kids to drink how to find their food, but those things are should be coming from inheritance, from our genetic code. And there are some other stuff, right? For example, learning English or in computer science and those all those things, and how to talk and how to do all those things we do. Those those are learned behaviors, learned intelligence, right? So AI is actually mimicking all those two types of intelligence. That is, we can have some hard-coded intelligence, and we can have some learned intelligence. That means we by learning to learning from the environment, we can get some intelligence. So machine learning is how. Hello, can you guys can you guys mute your. Okay, I have muted someone because if you have any unmuted, please make sure that you are muted, right? So otherwise, you would interrupt our discussion, right? So unless you are answering, so just keep it muted, right? Okay, so what you were discussing, yeah, the intelligence is that there can be intelligence that is inherited from or hard coded into ourselves or the living beings, or it can be a learned intelligence. And the machine, when it comes to artificial intelligence, the machines are learning. These both machines can have both kinds of intelligence. So, so the hard coded intelligence we can do with even with a small software program, right? With a Python code, you can achieve artificial intelligence. That is not actually that is artificial intelligence. You think that is not, that is just a program kind of thing, but we can write some code to, like when the temperature is higher than a certain amount, we can turn on the AC. That kind of understanding, and the response can be programmed with the machine. So that is also AI, form of AI. So the thermostat is a kind of mechanical implementation of AI in some sense. Uh, but so that is how the term has come into play, like the AI, artificial intelligence. But generally, but when we hear when people are discussing about AI, they are referring to much higher level, much deeper level of intelligence, right? So not the very small kind of that kind of very basic intelligence. So that is the difference. So machine learning is a specific form of artificial intelligence, which is about learning from the data, right? So the other type of intelligence can uh, so the other type of intelligence can uh, come from hard-coded system like expert systems, for example. Before the machine learning has come into play, there are a lot of hard-coded expert systems to do the things where they where we can automate the experts. For example, we can write automatic di diagnostic systems. Like you can write a lot of if-else statements, and then that would be a expert system, that is an AI system, right? And you can write some you can have some knowledge graph and traverse through the graph and find the answers to your questions. That is also a form of AI. And when it comes to these mechanical controllers, there's a mathematical subject called control theory. So using control theory also you can write do some uh, not the programming, kind of mathematical, with using mathematical equations you can manipulate, you can understand the nature and instruct the actuators to operate depending on these equations. Those kind of things are possible with AI, but the machine learning part is the part that the human, which is automating the part where the humans are learning, right? So and that is, that is the main most booming subject in these days, because with a lot of data without much expert knowledge, a machine can actually be a better intelligent species than humans, right? For example, ChatGPT, if you have worked with it, you might have seen that it is much more intelligent than any of a single person we know, right? So that means it has the expertise in almost all of the subjects. So none, no any person you might know that has a knowledge like uh, that is the difference. So they have come to this intelligence not using the input from human experts, but just learning from the data. That is the special thing with machine learning. We can learn from wait a minute. Sorry. Uh, that is the main difference between the rest of artificial intelligence and the machine learning. That is, AI can have hard-coded logic. The machine learning is all about learning from the data and building a model so that it can uh, understand the nature by based on the data. So that is, earlier it was started with statistics, right? If you have some understanding about statistics, right? When you get the mean of data distribution, that represents the whole data set. So you can have some understanding about how the distribution is, and the variance, you have some understanding how much the mean would vary uh, with some probability, right? So that is also a form of that is actually the beginning of machine learning. So that is not the actual meaning of machine learning, but those are the concepts from the statistics what we have come, and that subject has evolved into machine learning, where the uh, earlier forms of statistical learning has emerged into much complex way. Right, so we will discuss about this in this later. So when it comes to deep learning, it is about it is also a form of machine learning, which is much more complex, and it can learn with a lot of data. That means it can have scalable intelligence. That means with the larger model, you can train with larger data set. That means you can learn with a lot of data. When you have a complex deep learning algorithm, and you can have much more intelligent output, like for example ChatGPT. Right? So those are based on deep learning, but in our discourse we are not discussing about deep learning. We are only focusing about this purple color machine learning. So once you, in order to learn the machine, in order to learn the deep learning, you need to learn machine learning first, because that is the foundation of deep learning. So that is why we are going to learn this in this subject model. Okay. So deep learning is all about deep neural networks. I haven't mentioned it earlier. So deep neural network means which is a form of machine learning algorithm that is mimicking, that was trying to mimicking the human or animal brains. So how the neurons are working inside the brain, and people have found a way to uh, mimic the neurons using small uh, learning module, and with combination of those neurons we can have neural networks. So earlier there were no ways to have very deeper level of neural networks. So we are not going to discuss what is this deep depth means, but later recently people have found ways to how to deepen the neural network. So that is the birth of new form of AI that you listen day to day, like Midjourney, ChatGPT. All those things are based on deep neural networks. So we are not going to cover this. We are only focusing about machine learning, which is deep learning is also machine learning, but the specific deep learning algorithms and the neural networks are not included in this lecture, but the other foundation knowledge, the machine learning related knowledge is included in this course. So no need to talk about AI, because AI is actually a very loose term, as I said earlier, because even a thermostat can have is said to be having AI. So AI is a very loose term. The machine learning is the one that we have to master, because that is the way how we learn from the data. That means we learn from the environment and make models, and those models can have the intelligence that we have, like in humans. So this is what I have explained earlier. Yeah. If you have any questions, you can ask. Okay, so and the other thing is that when you are developing machine learning systems, you don't need much knowledge about the domain. For example, if you are developing a machine learning model for diagnosing patients, cancer patients, based on the data, you may not need a lot of knowledge about uh, cancers and all those advanced medical knowledge to make a AI system. That is the power of ML, because the machine learning model can learn it. You just have to give the data, required relevant data, in the suitable format, and you have to select the suitable algorithm, what is that you are going to learn, and then the machine learning will figure out how to classify the cancers and non-cancer tumors. That is an example, right? So you don't need that much of domain knowledge. So that means you don't need that much expertise to develop a machine learning model. That means you can become a doctor if you have enough data, right? So and some common belief misconception is that inside machine learning we have a lot of if-else statements. So that is totally incorrect, totally wrong, right? That means, as I said earlier, if-else statements are kind of, those are also AI, but these if-else statements belongs to expert systems, right? So you can have decision trees and that kind of, no, not decision trees, some tree-based uh, expert systems, right? Uh, those are not machine learning, because machine learning is, in machine learning you don't have to write any code. Code doesn't mean that you don't have to write anything. You have to write you have to specify the algorithm and so on, but you don't have to understand how this size is greater than this thing, you have to do this thing. No, you don't have to do it. The data will decide how the intelligence should be generated. That is the power of machine learning. You don't have to write any code to do the machine learning. You have to write the code to specify the algorithm and select the data that you want to put into the machine learning algorithm, and how to get the data and how to process the data before it is added into the machine learning model. That is to optimize the input and improve the performance. You don't specify any logic like this, after this should happen. No, we don't do it in machine learning, right? So have this very clear, right? AI can have expert systems which can have if-else statements, a lot of if-else statements in a very simple way, right? In machine learning, we don't have any that kind of logic to hard coded by an expert. We just give the data. So after this has happened, or with this information, this is the resultant data. We have a lot of data. We give the data into the algorithm, and algorithm will figure out, okay, so now this is how the nature is. So if I give new kind of data, I should give this type of output. So that is machine learning. So statistical learning is the earlier generation of machine learning. Right? So that means, as I said earlier, statistics is the grandfather of machine learning. So as I said, we can use statistics to understand the nature. So this has improved with time, and people have figured out how to use statistics to mimic the nature-inspired algorithms like neural networks and other decision trees and other algorithms that we are going to learn in upcoming lectures. So that is the birth of machine learning. So in the statistics, you should have learned, right? You have learned about statistics. So there you have, that is a science. You have everything is proven, everything can be proven, and it is based on hardcore mathematics, right? Statistics has a very rigorous foundation on mathematics. It's not a kind of alchemy, right? That means, for example, if you consider chemistry and you have some understanding about chemistry and the alchemy, so there's a clear difference, right? The chemistry is based on physics and it has a mathematical background. It is proven. And that is how the chemistry works. But when it comes to alchemy, alchemists are the older form of chemists that were trying to make gold and other chemicals without a knowledge about the theoretical side. So actually that time the theory was not there. So they were mixing all those things together and try to make gold, like turmeric and egg yolk and all those things. They were trying to make gold. So that's what the alchemy was doing. So statistical learning was like is like chemistry, and machine learning is like alchemy. But don't go wrong. Machine learning is not a pseudoscience, right? It can also be proven because we test with the data sets. So the difference is that sometimes we may not have a very clear understanding. That means the statistical, mathematical understanding how this actually works, like in statistical learning. But we know this works for previous data. So that is the difference between machine learning and statistical learning. That means for these previous data, this was working correct for 95% time. So that is the guarantee we have with machine learning. Because of that, we assume that the upcoming uh, results will also be accurate like this. That is the basis of machine learning. When it comes to statistical learning, that is more than that. So we can evaluate how we can logically evaluate how it is fitting into the model and whether they are correlated, and we can do much more. But it is less powerful when it comes to achieving higher level artificial intelligence like ChatGPT, right? So with statistical learning alone, you can't come up with advanced uh, artificial intelligence like machine learning and mid journey, right? So it is machine learning that uh, came into the power, and we were trying different people were trying different statistical algorithms. They have found very successful statistical algorithm, and they have developed it known as machine learning algorithms. And those are very complex if you try to understand in from the basis of mathematics. But for example, there can be a lot of partial differential equations and so on. So ordinary people would not understand. Even if that when that is implemented, the logic would be even more complex. So you may not directly understand directly how the statistics works there in each uh, location in your algorithm. You may not understand, but you have some sense, and that is why we are learning statistical learning, right? So in uh, that is the purpose why we are learning statistical learning is machine learning. But we'll discuss what we are going to learn, how we are going to focus in this subject model, right? So when it comes to statistical learning, because it is very formally proven, we can with mathematics it can be interpreted well. So, and because machine learning is also coming from the statistical learning, actually it is also statistical learning that is not very well researched yet. That is the gray line between statistical learning and machine learning, right? So this is something you can go and read when you go home, right? So I'm not going to discuss too much about this. So we have compared statistical learning and machine learning. Mr. Focus foundation, assumptions, and interpretability. Just go home and read it, so then you will have some better understanding. So the course structure is like this, right? So when is this lecture going? Should be ended? Excuse me.
1 o'clock.
1 o'clock. Right? Okay. Okay. Thank you. Okay. So this course has the following structure. Uh, so we are from previous years in our module. That means undergraduate studies, we have tried different things. So this year our focus is mainly on machine learning, right? So I am actually my specialization is based on this area, the machine learning, right? Because that is the practical things that are going on in the industry, and that means when you go to the industry as a MBA and graduate, and if you go to work with some machine learning projects, this knowledge is the one that is going to be used, and you would be able to do everything. That means you now you have learned the last semester you have learned about Python, and this one you are going to learn about other remaining machine learning related Python libraries and the concepts. So then you should be able to do the machine learning as demanded in your company or your own business or something. And so that means the purpose of this course is to move you into that level, right? Except for the deep learning, because I think we may have some another course deep learning. I'm not sure, but anyway, we are going to focus mainly everything except deep learning in the machine learning field to end to end. And that is the idea, right? And we are going to trying to focus everything about machine learning the practical way, completing the whole machine learning life cycle, right? Anyway, so that means the statistical learning is mainly focused on theories. So if we focus too much on statistical learning, we may be able to come up with the practical stuff, right? So that means you may start uh, find the solutions and so on, but when it comes to practical machine learning, there are a lot to know, a lot to learn, right? So we are focusing mainly on practical machine learning, right? So, but and we are going to once depending on your understanding the way that you are learning, if you are very good at learning, then we can move into the next phases about explaining how this works with statistics. So that is the statistical learning part that we will come up. So when we are introducing new machine learning, we are trying to give some understanding uh, about, about these algorithms with statistics and with statistical background. And but we are not going too much deep into proving those mathematically formulas and those things. We are just stating you can. Actually, there are a lot of content in the internet that you can find how to prove those formulas and so on. There are a lot of videos and so on. So here, what we are mainly focusing is you to getting your head start with machine learning, right? And have some good correct understanding and the vision and the basic technical knowledge you require to be successful in this field of machine learning, right? So that is how the priorities are we have identified in this course. Okay, so for your reference, this module is not enough for definitely not enough for you to learn machine learning if you are trying to master in it. So you have to learn by yourself. There are lot of things to learn, right? So most of the data scientists in these days have PhDs. So there are a lot of, so that means there are a lot of fields that are emerging, coming into the machine learning field. So you have to learn yourself if you want to be a professional in this field. The first thing you can do is you can do this free online course in Coursera with the machine learning specialization, right? So go to this link and you can do it. So there, if you can get the this financial aid by filling some forms, then you can get it for lesser fee. Or otherwise, you can just go into subscribe it into the course as in the audit mode. That means you will not be able to do the exams, but you can watch all the videos and then you will have a good understanding about machine learning. So this is a beginner's level course. Uh, there are 2 courses in this specialization, so you can try it. So that is very good. So that is offered by deeplearning.ai and Stanford University. So that is because of that we can recommend this as a good course. So, and if you want to learn more, if you are more interested about statistical learning, you can download the book about statistical learning. So in this statlearning.com, there are two books. One is about statistical learning with R, and another book is there about the statistical learning with Python. So because we are moving with Python as our main technology, we can you can download this Python book from this site and you can read it. Right, that is those are the main two references, and there are many the references in the internet. Like there is a if you want to learn deep learning, there's a course in MIT, and for the statistical for machine learning, there are some course videos done in 2018 by Stanford University in Stanford University YouTube channel. You can go there and watch all of them as well if you are much more interested. And there are some other Udemy courses and any other Coursera courses as well. And if you want to learn improve your programming skills, there are online tutorials like tutorial points, tutorialspoint.com or something like that. So just go there and do some online tutorials to get your hands dirty with Python libraries, mainly NumPy and Pandas and scikit-learn. NumPy and Pandas are the most important. Scikit, so NumPy and Pandas are mainly required to do basic data science related stuff. Right? So next week we will be introducing you with exploratory data analytics. Right. So for that you need to have some knowledge about mainly pandas. Right. So just go through these two, NumPy and pandas, and scikit-learn when it comes to the upcoming lectures. Yeah, most of the machine learning, that means non-deep learning machine learning, may involve scikit-learn library. So this is one of the main highly used machine learning library for machine learning, for Python-based machine learning. And you can do when you have some tricky questions where you can't find exact logic, maybe you can get the help from ChatGPT, but don't believe everything as it is. Because sometimes ChatGPT may tell things like exactly correct with very high confidence, but they may be totally incorrect. But because of that, take them with caution. But ChatGPT is a very easy and framework, very good tool that you can use to learn about these complex subjects, because there are not many people that you can get help from, but ChatGPT can give you answers very clearly, and it can summarize you most of the answers, but make sure you double check with the other sources before you come into a conclusion when you get from the answer from the ChatGPT. So you can even get the code from ChatGPT, you can get it right, but not for the quizzes and exams at all. Right. So in all other cases, you can use ChatGPT for writing code. I heard that in the paid version of ChatGPT, you can get the code which is also tested in the ChatGPT itself. So if the tests are not passing, it rewrites the code again and again until it passes. That kind of advanced features are also available in ChatGPT. So you can use that as well, other than using tutorials, videos that are available in Google. Okay, someone. Okay, if you or not asking any questions, just make your mics mute. Okay. So only when you want to ask some questions, you can unmute and ask. Right. Okay. So when it comes to, so we will start from the machine learning, right? So because that is our main focus. So what we are expecting from the machine learning, right? So let's start like this. So say we have some data, right, about some subject or some aspect that we have worked with manually or using some other means. We have done a lot of, we have got a lot of experience, and with some monitoring tools, we have collected a lot of data. With these information, we are getting this output, right? So we have collected a lot of information like this. Those are known as data. So we are going to, what we want is to, computer or machine, we provide those data and we ask the data to get the insight of that data into a model, right? uh, how the machine does this, so it would try to map from how the information is uh, included in this data, and it would try to figure out and create a model about this data, right? And the idea is that after it is after the model is trained, then means we are making the model correctly so that we can predict new values, new predictions from for new incoming data. So let's give you an example, right? So for example, think that when you have some certain customer behavior when in your website, like if for example, if he has if you have some there are personal data like gender, age, and you have also have the information like his web browser, whether it is a Firefox or Google Chrome and so on, and the geographic location of whether he's coming from Sri Lanka, visiting from Sri Lanka, United States, and so on. So with those data, uh, the website has the information whether that person has bought a certain, say, a perfume, right? Whether the person has bought a perfume based on this information. So the company has collected a lot of information like this. That means for this demographic means this age and this gender in living in these geographic areas with this profile has purchased this perfume. Right? So we have a lot of data like this, and we provide this data into the machine, and the machine will start to understand what type of person would buy this perfume. It can't tell you, but what it can does is when you give a new set of data, like when a new visitor comes with certain age 48 and male and some kind of thing, that kind of data, and it can predict whether this person would buy this particular perfume. If we can predict this, that is what is expected from our machine learning model. Right? So that is useful because then the website can advertise that person about similar perfumes so that he would buy more. That is one. It's a good example of using machine learning, right? And it is similar. So how the machine learns? So it is similar to how the humans or dogs or any your pets or any other animal learns from their childhood. Right? So So you, for example, you show your kid a set of pictures and of oranges and apples, right? So you tell him these are oranges and these are apples. And so then after some time, you give him a new fruit with it is apple or orange, and your kid can easily identify whether it is a apple or an orange, right? So he has learned this from the previous examples. So how he has done it? So he has figured out some features, the color and the texture of the fruit, the shape, and how he feel it. All these things as new features, and he has internally inside his brain, he has trained a model how to classify apples and oranges. So machine can also do it. Throughout this course, we are learning how similar kind of models are learned, and not directly related to image classification, or when we are given photos of oranges and apples, but with some other uh, type of data like tabular data, not the pixel values of images, but some when you're given some tabular data like age, demography, and the geolocation and those things in the table, then the machine can learn it. So in this module, we are mainly focusing about this tabular data and how those data can be used for predicting new values. So once for so when we have trained the model, we have to test it, right? So what we do is we once we give some enough information data, we make sure that the machine learning model was created or is known as training. Training means we are giving some data and ask the algorithm to learn from it, like the child has learned how to classify apples and oranges. And once it has trained, we have to make sure the model can correctly classify the apples and oranges, right? So how we do it is that we don't provide all the data that we have got. That means suppose we have a lot of apples and oranges, we don't show all the apples and oranges to the kid, and we keep some of the apples and oranges for testing purposes. So once the kid has learned to classify apples and oranges, we provide the new apples and oranges to the kid and see whether the kid can classify the new fruits, the new apples and oranges. Similarly, we keep a separate data set for testing purposes, a small data set, a smaller data set than the trained data set. And we provide that data set into the model and see whether the model can predict correctly. And for those predictions, we can calculate the accuracy. If the accuracy percentage is higher than a certain amount, we can use this model. If it is not, we have to start training the model from the beginning. That means we have to check whether our data is correct, whether our algorithm is correct, whether we have pre-processed the data correct, and we have to go through the whole life cycle again to train another model until we are satisfied with the accuracy numbers. That is what we do in machine learning. That is what we want in machine learning. So this is what we do in machine learning. First we find a data set. Right? So I think you might have heard about these two concepts like supervised machine learning and unsupervised machine learning. Right? So in supervised machine learning, we have x values and y values. Right? You know, right? So the data has x values, that means the independent variables, and the dependent variable we call it as a supervised variable. For example, in the previous example, so the website has the information about age, country, and the web browser. Those are X variables. So if the visitor has purchased the perfume, it is a Y variable. So that is because it is the dependent variable. Y variable is the dependent variable. We call it dependent because the Y is dependent on X, right? X are the age uh, and the demography and the geolocation and so on. So we have a lot of data with X values and Y values. So that is a supervised machine learning data set. So we give that this data. So we have to find this type of data for supervised machine learning problems. And there are another type of machine learning known as unsupervised machine learning, where we only have X values but no Y values. That means we only have a data set which is not labeled. So the Y values are known as labels. So that means when it comes to a data set like as I previously mentioned, you have to label whether this person has bought the perfume or not bought the perfume. So that is known as labeling. So labeling is kind of expensive, but in some cases you may only need to uh, cluster the data into some segments. So in that case, you may not need to have Y values. We just need to uh, ask the algorithm itself to figure out how to cluster this data into several around 5 clusters, for example. How to do it? The machine learning algorithm will figure out how to divide the given data set into 5 classes. And when new data comes, it can figure out what is the cluster that the new data point belongs. So that is known as unsupervised machine learning. So there you don't have to label the data. You just give the data and the machine learning algorithm will figure out how to uh, class the data into several classes. For example, k-means clustering, if you have that is a form of unsupervised learning. So the linear regression and the logistic regression, those are supervised machine learning algorithms. And when it comes to training, as I said, we give most of the data for training. That means around 80% or 70% data for training. We keep the remaining, for example, 20%, 30% data for testing. That means we randomly divide our obtained data set into two, one for testing and one for training. We use majority of the data set for training data set for training the model, building the model, and we use the remaining data set, the small data set for testing whether the model has the accuracy level that we want. Only if the tests are passing, we can use the modeling production. So this is an example, right? So there are two types of variables, as I said. Independent variables are also known as features, right? So if I say features, that is also referring to independent variables. So in the language of statistical learning, we call them as predictors. Or also in our lectures, we call them as simply known as X values, right? And for the dependent variables known as target variable or response variables in terms of statistical learning, we call them as Y values, right? So this is a very small example, but don't misunderstand. We should have a significant amount of data to train a machine learning model. So these 3 data points are not enough at all. But because we can't draw a lot of data in lecture slides, I have added only a data set with 3 data points. The first 3 data points as for training and testing, and we want to predict the last row of data, right? So here we have the x features or the independent variables, x1 as GPA, x2 as income, and x3 as the IQ of a person. So for the dependent variable, we take it as life expectancy. So we can get this data from the population data set, and we can find how he has got his GPAs and how this income and the IQ has varied, and how it has decided whether it has any it should have some kind of dependency on the life expectancy, and we have found the life expectancy in years as the y variable. And for a new person who has got this amount of GPA, income, and IQ, we can expect how much you live. So this kind of information can be actually used for life insurance policies, right? So for how to define the premium of life insurance. So if you can master these skills. So for in this example, these three data should be taken for training and testing, and this one is the one we are going to predict. So first thing we are going to do is we are going to train from the first two rows, first two data points to train the machine learning model. Third one for testing, and fourth one is for predicting. That is what happens. So we use the first two data records for training, and we create a model. And the second point, we are testing with the third row, and we get accuracy of 80%. Because of that, we go to the third variable, the predicting phase, where when we have new data, like in the fourth, even in the fourth record, you can predict the life expectancy. So this data is not correct, right? This model, I have just added some random values. If you try to learn it, this will not work, but I'm just giving you an example. Two records are not adequate at all, right? Because when you're learning model, you need actually at least several hundreds of data to train the model, right? In general, right? So this is how we do it, represent it as in mathematical terms. Okay, I think the time is also moving away. Okay, let's try to do it quickly. So we represent the x values as x1, x2, x3, and represent y as y, right? And we can represent this function that we are going to approximate with the machine learning as f. So this is, suppose this is the real ground truth. We call it ground truth value. That means the real y value of given x values. So this is the real function that exists in the nature, right? So we can give it as y equals fx. So, but when we learn the model, we are just trying to approximate this natural fx function. So we call it as f hat x, right? So this is actually approximation for fx. So when we are predicting with f hat x, we are not getting the exact y because it's just an approximation. We are getting an estimator for y, which is known as y hat, right? So because y hat and y are not equal, we have an error. That is difference between y and the y hat. We call it as epsilon. Right? So that is represented from this formula. So this formula is a commonly used formula. So that is why it is important to remember it. So there are mainly two types of machine learning: supervised machine learning, regression, and classification. Right? When the y variable is continuous, for example, it's a temperature or the height. So because it's a continuous variable, we call it as a regression problem. When the y variable has very discrete few number of classes, for example, if you classify for passed and not passed, or will some age groups as the y variable, so those are classification problems. Right? So take this example. There so if you can go home and see. And so here, real they they are going to estimate the sales price of a house. So uh, this should be a regression because we have the data, both x values and y values, right? Uh, and because and it's a supervised learning algorithm, and it's a regression algorithm. So in this case, we have doctor wants to diagnose the cancer as malignant or benign. That means whether it is cancer or not, using 500 tumor label data. So label data means it is a supervised algorithm. So because there are only two cases, malignant or not malignant, there are only two classes, not a continuous variable. It's a discrete one, so it should be a classification algorithm, right? So when it comes to unsupervised machine learning, that we can have many x variables, but not y variables. So for examples of machine learning, unsupervised machine learning is clustering, dimension reduction, and anomaly detection. So for example, if a owner wants to categorize the past 10,000 visitor into 10 types of people, right? For his understanding, he can use unsupervised machine learning. For example, you can use k-means clustering. So we will learn that. So okay, so that's all for today's listen. If you have any questions, you can ask, or we can finish our session. Are you okay? Okay. So shall I stop the recording?